I welcome you all in this presentation related with the subject fundamentals of surface engineering, and we are talking about the abrasive wear. We have seen that whenever a hard particle is rubbed over the another metallic surface, the material is removed by abrasion. But there can be the two broad types of the abrasive wears, one where one hard particle is firmly held and it is rubbed against the another surface, and the another type of the abrasive wear is when the hard particle comes between the two interacting surfaces and leads to the three body abrasive wear. So, depending upon the loading conditions, depending upon the location where the abrasive particle is present, it can be two body or three body abrasive wear. This is what we have already talked, and then there can be open or closed type abrasive wear, where hard particle comes between the two firmly placed components or surfaces like this, then it leads to the closed one, or one hard particle firmly held and pressed against the another component like in emery paper and wherever polishing is performed. So, that forms the closed abrasive, and when the abrasive particles are allowed to move freely then it over the metallic surface, then it leads to the open abrasion, and then according to the kind of the loading, there can be low stress abrasive wear condition or high stress abrasive wear conditions. So, in case of the low stress abrasion, in case of the low stress abrasion, wherever the conditions exist like in three body abrasive wear, the loading conditions are such that the abrasive is able to retain its size and shape and it is not crushed. So, that is the state of the low stress abrasive wear, while in case of the high stress abrasive wear, wherever the particle is present, loading is such that the abrasive particle is crushed and it is broken, it is damaged under the high stress abrasive wear conditions. So, this is the difference. Under the low stress abrasive wear conditions, the particle largely retains its size and shape, while under the high stress abrasive wear conditions, the particle is crushed. Then again under the category of the three body abrasive wear, there is one gouging, which combines the impact plus abrasion effect. Then there is high stress abrasion, where the particles are abrasive particles are crushed, and low stress abrasion, where the no major damage to the abrasive particles in course of the abrasion. So, these are the as per the loading conditions, as per the situation where abrasive particle is present, there can be various groups and classification of the abrasive wear. It may be like open or close, it may be two body or three body, it may be low stress or high stress abrasive wear. Now, we will see the way by which material is removed during the abrasion. So, abrasive wear mechanisms. Basically, there are two broad categories of the but there are finer other mechanisms. One is called plowing. It is also written as plowing, and then there is metal cutting, or it is called cutting. So, plowing leads to the low rate of the abrasion, while the metal cutting causes very high abrasive wear rate. Then there are other finer mechanisms. One is called surface fatigue. this also leads to the low wear rate, and it happens due to the continued subsurface layer deformation, thereafter nucleation and the growth of the crack leads to the removal of the material in form of the chip. Like this is the surface, and it is being abraded continuously. So, due to the continuous surface layer and subsurface layer deformation, a crack is nucleated in the subsurface region, and in its growth leads to the removal of the material in form of the particles. So, this is the like say micro fatigue, we can say micro fatigue. In case of the brittle materials, there can be micro cracking, also a mechanism which leads to the removal of the material. So, the ploughing and the metal cutting, these are the two mechanisms which are mostly for the soft and the ductile metals, while micro cracking mostly observed in case of the brittle materials. However, under the actual abrasive wear conditions, there will always be combination of the ploughing, metal cutting and micro cracking as per the kind of the material which is being considered. So, in which way we can express and how schematically we can understand these wear mechanisms. For that we need to see certain diagrams. So, again going back to the what we have talked, this is the open abrasion system, this is the open abrasion system, where open two body abrasion, the abrasive particles falling freely onto the surface. So, this is the open two body abrasion system, and when the one member and the two members are relatively fixed with each other, and means their relative positions are fixed, and then thereafter relative movement causes the removal of the material. Like in similar to the machining, this forms the close two body abrasive wear, and the open three body abrasive wear is this situation where this is the shovel which is being used to remove the sand. So, sandy soil is being penetrated with the help of soil, or so this is the case of the open three body abrasive wear, and this is the example of the closed three body abrasive wear, where between the two jaws the abrasive particles are fed and they are crushed. So, these are the mechanisms about abrasive mechanisms, abrasive wear mechanisms about which I have talked, like the gouging, which combines the impact plus abrasion, high stress abrasion where particles get crushed, and low stress abrasion where particles largely retain their size and shape, but remove the material by abrasion through metal cutting or the ploughing. So, in case of the low stress abrasion, the low impact angle abrasive wear causes the scratching abrasion, while the high angle of the incidence causes the erosion. These are the five different mechanisms about which I have said. The ploughing, metal cutting, micro fatigue, micro cracking. Wedge formation also sometimes takes place, but these are the two mechanisms which do not contribute much towards the material removal. By and large, the material is displaced plastically. So, in these cases, this is one ploughing mechanism where like over the soft metal we forcefully penetrate one tool. So, the material is displaced sidewise, and once the tool keeps on moving or abrasive particle keeps on moving, so this phenomena will keep on displacing the material sidewise from the path of the particle. In this case, there is no major removal of the material, only the displacement of the material takes place. So, this is what we can see, this material is being displaced by the hard particle which is rubbing the surface, and this displaced material may look like this, where this is the kind of the groove which has been formed, and this has been displaced sidewise like this. So, both side will see some piling up of the material, while in case of the wedge formation, apart from this displacement of the material is one piling up of the material is also will also be taking place ahead of the abrasive particles. In case of the micro cracking, continuous rubbing of the surfaces by the abrasive particles leads to the deformation, followed by work hardening, and when material loses its work hardening capacity, then crack nucleation and their growth, and subsequently the coalescence of the cracks or joining of the cracks leads to the removal of the material in form of the debris. So, this is what happens in case of the micro fatigue. So, since during the operation, if the material is continuously displaced from its position due to the abrasive action, then when the deformation, continuous deformation causes the significant work hardening, which eventually loses its ability to get work hardened further, and in that case the cracking starts. So, the crack nucleation and its growth leads to the coalescence of the cracks, and which finally leads to the formation of the wear and debris. So, this is what we can see here in case of the micro fatigue, and in wedge formation also there is no major removal of the material. In case of the micro cracking, this happens when the material is having the limited, very low ductility, and brittleness is high. So, whenever the abrasive particle will be moving, it will try to displace the material, but due to the limited ductility, instead of getting displaced, it will lead to the formation of the number of cracks, and number of cracks when since the material is having limited ductility. So, the formation of such kind of cracks will be removing the material in form of the fine debris particles. On the other hand, when the abrasive particles work at a particular critical angle, it leads to the formation of the chips in by the shearing action. So, this is typically observed in case of the soft and ductile materials, where large amount of the material is removed by the cutting action. So, if we see here degree of the wear which is encountered through the different mechanisms, in case of the ploughing, the removal of the material is very limited. Somewhat removal of the material takes place in case of the wedge formation, and maximum removal of the material takes place in case of the cutting. So, the ploughing and the cutting, these are the two extreme mechanisms which we will see how these will be varying with the variation in the hardness of the material. So, this is how we can say whenever their material is subjected to the ploughing, then it leads to the displacement of the material sidewise and it forms the wedge like this. So, under these conditions there is a limited removal of the material, but whenever the material is having limited ductility, and then in that case the deformation, sidewise flow of the material will also be limited, and it forms the deep scratch, and such kind of the scratching causes the loss of the material. This is like a removal of the material by the cutting in form of the ribbon, form of the chips, and here some of the material is displaced ahead of the abrasive particles, but some of the material will be displaced sidewise. This figure particularly shows when which type of the abrasive wear mechanism will be dominating. So, what we can see here, when the material is really hard, we can see then so in axis we have the hardness of the material, and in the y axis we have the abrasive wear resistance. So, abrasive wear resistance, here what we can see, when the material hardness is high, mechanism responsible for removal of the material is basically micro cracking, and some micro cutting will be taking place. On the other hand, when material is having very low hardness, then it is basically the ploughing, which will micro ploughing which will be taking place. In between it will be the combination of the ploughing and the micro cracking. So, if we see which kind of the metal system will be subjected to the plowing, the materials which are pure, soft and ductile. So, pure metals. On the other hand, hard and brittle materials like ceramics will be experiencing the micro cracking and the combination of the micro cutting, and the plowing and micro cracking combination of both these is observed in those metal systems which will be having the combination of the both hard and soft second phase particles, like matrix is soft and tough, while the ceramic particles or other particles, second phase particles which are hard and brittle. So, in that case a combination of the plowing and the micro cracking will be observed. These are some of the characteristics or the factors which will be affecting the abrasive wear of the material. So, now we need to see one simple diagram how the material hardness changes. So, if we see there are different metal systems which will be showing the different value of the hardness in annealed condition. Annealed condition means that when material is subjected to the high temperature exposure for longer period, so that it does not have any work hardening effect. So, soft metals like silver, then aluminum, then iron, then cobalt. They may have the variation in the hardness like this, and accordingly what we will see. So, a material hardness in annealed condition, hardness in annealed condition, and what it will be showing the wear resistance, increasing wear resistance. If we see in annealed condition, it will not have any work hardening effect, there will and the flow stress will be same as that of the yield strength of the material. But we know that whenever any material is subjected to the surface layer deformation either during the adhesive wear or during the abrasive wear due to the effect of the abrasive particles movement under the external load, surface layer deformation will be leading to the work hardening effect, and under the work hardening effect obviously the hardness of the surface hardness will be greater than the bulk material hardness. So, this leads to the somewhat better resistance to the abrasion, and this is observed primarily due to the surface layer deformation and the work hardening effect. So, if we see the another interesting diagram, then what we can observe this like work hardened condition. So, it will be going like this for the pure metal hardness variation, say for silver, aluminum, iron, cobalt. So, when we work harden the material, this is for the pure metal. When we work harden, there is increase in the hardness. So, hardness will be increasing with the deformation. So, what it is showing, there is a deviation from the hardness of the material in the in the annealed condition, hardness increases, and increase in hardness due to the work hardening effect increases the wear resistance. So, this is what is the typical diagram which shows that material in work hardened conditions shows the better abrasive wear resistance as compared to that in annealed condition. Now, this slide basically shows the different factors which will be affecting the abrasive wear. So, there are basically the three types of the factors. One is service condition related factors. Service condition related factors means what is the kind of the load, what is the kind of the relative speed of the abrasive particles, what are the what is the distance travelled or the length which will be covered by the abrasives during the service. Then what are the kind of the abrasives which will be interacting with the surface of the material, like their type of abrasive affecting their determining their hardness, and then the size of the abrasive particles, shape of the abrasive particles. These are the very important factors which will be governing the abrasive wear behavior of the material. Apart from this, there are other material related factors and the surface condition related factors, like the abrasive particles are interacting with the surface at under the ambient condition or at a high temperature, in the dry condition or in the humid condition. So, these factors will be affecting the abrasive wear. For example, if some kind of the heating is taking place, so high temperature will be lowering the hardness of the surface layers, a reduction in hardness will be increasing the abrasion tendency, and so the abrasive wear will be increasing. Similarly, the material related factors, there are two broad categories as far as the material is concerned: mechanical properties and the metallurgical properties of the material. So, in the metallurgical properties, basically what type of the phases it is having, which type of, whether it is simple soft matrix or it is the combination of the soft matrix and the hard particles like carbides, borides and oxides are also present. So, basically the type of the phases or the constituents which are present. The second aspect is what is their size and distribution, in what size these particles are present and how are they distributed. Among the mechanical properties, it is basically the combination of the hardness and the flow strength of the material. These are the two important mechanical properties which will be governing the abrasive wear behavior of the material. So, now coming to the parameters which are related with the abrasive particle characteristics. So, abrasive particles are normally harder than the workpiece material surfaces, but these can be the softer also. So, with respect to the workpiece material, what is the hardness of the abrasive, that is used to define the abrasives as a hard or soft abrasives. So, hard abrasives are those which are having the hardness greater than the workpiece material, and soft abrasives are those which are having the hardness less than the workpiece material. So, most of the time what we will see that abrasives are harder than the workpiece material. So, when the hardness of the abrasive is too high, hardness of the abrasive is significantly higher than the workpiece, like abrasives which are harder than maybe like say 1400 HV or 22,000 or 2200 HV. So, these are the very hard abrasives as compared to the workpiece, which may be like 200 to 400 HV hardness value. So, here if the hardness of the abrasive is very high, then it does not affect the abrasive wear behavior appreciably. So, this is what is written: wear is independent of the abrasive's hardness if the abrasive hardness is too high than the workpiece material. As the hardness of the wearing material approaches the abrasive, then the wear rate decreases or wear starts decreasing. So, if the hardness of abrasives is almost close to that of the hardness of the workpiece, then it plays a big role as far as the abrasion is concerned. So, if the hardness of the abrasive is less than the workpiece material, then the wear decreases rapidly with the increase of difference, which means if the abrasives are very soft, then and as the difference of means if the softness increases, means the difference in the hardness of the workpiece and abrasive increases. As far as the lower hardness of the abrasive with respect to the workpiece is concerned, then it will be leading to the reduction in the abrasive wear. So, if we compare the hardness of the abrasive and work material, then we can find a ratio. So, ratio of the hardness of the substrate and the hardness of the abrasive. So, if the hardness of the substrate is less and hardness of abrasive is more, then it will be causing the higher wear rate. So greater is the means lesser is the value of this ratio, greater will be the abrasive wear rate or abrasion of the material. If the two are very close, means the substrate hardness and the abrasive hardness is very close, then it will be causing the lesser wear rate, lesser abrasion. And further, if the ratio is greater than 1, means the hardness of the substrate is more than the hardness of the abrasives, and this will be reducing the abrasion of the workpiece further. So, if the hardness of the substrate is very less and hardness of the abrasive is more, then it will be causing the higher wear rate. So, this is what has been detailed out here in this slide. Hard abrasives are those whose hardness is greater than the workpiece hardness, and soft abrasives are those whose hardness is less than that of the workpiece hardness. And wearing action of the soft abrasive is similar to that of the hard abrasives, but it is modified with the increased damage to the grit size. So, soft abrasives will be modified very rapidly as compared to that of the hard abrasives in course of the abrasion. And when the scratching action is stopped or it is reduced significantly, when the yield stress of the wearing material and the abrasives are approximately same. So, means if the hardness of the workpiece and abrasives are almost close to each other, then it will be causing the lesser abrasion. Now, here I will summarize this presentation. In this presentation, basically I have talked about the various factors that affect the abrasive wear behavior of the material. Thank you for your attention.